Hi, I'm Patty Betzing. I'm from Eastmont High School, and today we're going to be working on double angle formulas. This is an extension of what we were doing in the last lesson. We want to be able to prove and use identities and the formulas involving double angles, and we also want to be able to take expressions with higher powers and simplify them down into single powers. So on the document camera here are the objectives if you need to write those down. Now we're going to start, I'm just going to give you the identities that we're going to be using today. And I think I'll take a second while you're copying these down, and I'm just going to go through a proof of one of them, and you'll see that they all are very easy to prove. So I'll just do the first one here. So if I take the sine of 2 theta equals the 2 sine theta cosine theta. So that's the identity I'm trying to prove. So typically when we're solving identities, I like to work with the most complicated side and simplify it down. When I look at this, it's kind of hard to decide which one is most complicated. Since this one, the angle is 2 theta, I'm going to start by expanding this out as a sum and then using that to hopefully simplify down to give me 2 sine theta cosine theta. So the first thing I would do is think of this as the sine of theta plus theta equals 2 sine theta cosine theta. And then on this one, I'm just going to expand it out using my angles, my multiple angle formulas from yesterday. So I'm going to have sine theta cosine theta plus, now typically it's cosine and then sine, but since it's multiplication and that's commutative, I'm going to do it any way I want, so I'm going to do sine of theta cosine of theta equals 2 sine theta cosine theta. Let's put my little marks there. Since I've got two of the same things, I'm going to combine like terms, and you can see that that gives me what I had on the right-hand side of my equation. And that one is proved. And I don't know if these will be exercises in your homework, but proving these two are equally simple. It's just going through the process of expanding them out like this and then solving. Okay, so here's a type of problem that we're going to run into in this section. So they're telling us that the sine of theta is 3/4, and they're also telling us that theta is in quadrant 2, and they want us to find the quantities of the cosine, the sine of 2 theta, and the cosine of 2 theta. So again, we talked yesterday with a similar problem, but I'm going to draw my reference triangle, and I know I'm in quadrant 2, so I'm going to draw it up here. And if this is theta, this is my reference angle. So the opposite is 3, hypotenuse is 4. Since I'm going to be doing the cosine, I know I'm going to need to find this adjacent side, so I'm going to start by using the Pythagorean theorem right now and getting this side. So 4 squared minus 3 squared equals b squared. I'm referring to this as b right now. So I have 16 minus 9 is 7. So b ends up being radical 7. So for radical 7 there. Now, since this is on the negative x-axis, I'm going to go ahead and put my negative sign there. Just that way when I use cosine or tangent, if I was working with tangent, that negative would be there and the sign of my problem would be correct. I should still always think about whether my sign should be positive or negative based on the quadrant I'm in. So I know that the cosine of theta is just going to be the adjacent, which is negative radical 7, over the hypotenuse, which is 4. So that one is done. So I have the sine, and I have the cosine. Now when I do the sine of 2 theta, which is the second thing they asked me to find, I'm going to start by expanding this out. I'm going to use the new identities that I've just got. So the sine of 2 theta, I know is equal to 2 sine theta cosine theta. So I'm going to write this as 2 sine of theta, which I know, cosine of theta, which I also found here. I'm going to plug those in. So sine of theta I know is 3/4. Cosine of theta I know is negative radical 7 over 4. And then I'm just going to multiply this out to simplify my answer down. So when I multiply, actually I'm going to reduce. I see this 2 and this 4. And since I'm not working with a calculator, I like to simplify as I go. So I get negative 3 radical 7 as my numerator. and my denominator becomes 8. So that is equal to the sine of 2 theta. Now I would suggest you pause the video and try to do the cosine of 2 theta on your own, and then we'll go over it together here in just a second. Okay, so if you tried it, hopefully you compared answers, and I'll do it and we'll make sure that we all have the same answer. So if I'm looking at the cosine of 2 theta, I'm looking at my new identities, and I'm going to expand this out to cosine squared of theta minus sine squared of theta. Remember, I know cosine and I know sine. So cosine of theta is this. So I have negative radical 7 over 4 squared minus 3/4 quantity squared. So when I square that out, I get positive 7 over 16 minus 9 over 16, which gives me negative 2/16, which would be negative 1/8. So that is the value of cosine 2 theta. Hopefully that's what everybody came up with. So this box is part of it. And that one is done. Now, just when you do problems like this, just be very careful with the quadrant you're working in. So if you're working in quadrant 3, the sine and the cosine are both going to be negative. If you're working in quadrant 4, the sine will be negative, but the cosine will be positive. So you need to be very careful of that. Okay. So we'll try another one. And this one is very similar to the one that we just did. So take a second and look at that and think about things that are similar and things that are different compared to the last problem that we did. So on this one, I still have a sine, but I've got x equals instead of sine of theta equals. They're essentially asking me to do the same thing. I'm trying to find the sine of 2 theta. They're wanting it in terms of x. So I know that my answer is going to have that variable x in it when I get done. So if I need to know the sine of 2 theta, I'm going to go ahead and write down that because I know that that's what I'm trying to find. And I'm going to write down that double angle identity, which is 2 sine theta cosine theta. So I know that in order to solve this problem, I need to know what the sine of theta is equal to, and I also need to know what the cosine of theta is equal to. So it tells me that I'm working in quadrant 1. So I'm going to go ahead and draw a reference triangle in quadrant 1. Now I don't know how big this angle is, and it doesn't matter because I am in quadrant 1. But when I look at this, I can't label anything because I don't know what the sine of theta is equal to. I don't have a trig ratio to put into my triangle. But I can take this and solve for the sine of theta by just simply dividing off that 5 from both sides. So I know that, let's see, I'll do that over here. If x is equal to 5 sine theta, if I divide off the 5, I know that sine of theta has to equal x over 5. So when I come to my reference triangle, the side that's opposite will be x, the hypotenuse will be 5, and I don't know the adjacent. Now, if I need the cosine, I'm going to need to find this. Now, since they want my answer in terms of x, I'm just going to go ahead and solve for this side in terms of x. So I'm going to use my favorite formula, the Pythagorean theorem. So I have 5 squared minus x squared equals, we'll call it b squared. So I have 25 minus x squared equals b squared. So I end up with that side being the square root of 25 minus x squared. So I'll mark that down up here. Radical 25 minus x squared. Okay, now, I know that the sine of theta is equal to x over 5. And I need to know what the cosine of theta is equal to. So I look at the adjacent, which is radical, or the square root of the quantity 25 minus x squared, over the hypotenuse, which is 5. So I know sine in terms of x, I know cosine in terms of x, and now it's just a matter of substituting everything into my equation, or my expression. So I have 2, the sine of theta, I'm going to put in x over 5. For cosine, I'm going to put in this So I have the square root of the quantity 25 minus x squared over 5. And I'm going to clean that up if I can. There's not much I can do. There's no canceling really. But I do end up with 2x radical 25 minus x squared all over 25. And that's how we would express the sine of 2 theta. This problem. And we could do that with the cosine of 2 theta or anything that they ask us. We could just solve for these and then substitute them in. Now, here's another one that we're going to try. On this one, they want us to prove the identity. So I notice that I have a multiple angle here, but it's not a double angle. And I have my double angle identities for sine, but this is a 3 theta, and I only have an angle or an identity for 2 theta. So what I'm going to do with this is I'm going to go ahead and just do what I can. So I'm going to break this down to the sine of 2 theta plus theta. And those two things are equivalent, so I'm just going to put my equal sign here. This side of my equation is staying the same. Remember, when we work identities, we want to tend to work down one side of the equation first. So I'm going to go ahead and expand this out. Now this is not a double angle, so I have to use the angles from yesterday. So I'm going to have sine of 2 theta cosine of theta plus the cosine of 2 theta sine of theta. Now I have some double angles. So on these I'm going to use my new double angle formulas. So the sine of 2 theta is going to be 2 sine theta cosine theta. And then don't forget to put that cosine theta back in there. Plus cosine of 2 theta. That one was cosine squared theta minus sine squared theta times the sine of theta. Be very careful when you do these that you use parentheses. A lot of students will forget to put the parentheses, and then they'll also forget that they need to distribute that sine of theta into both of these values. So be careful with that. This one, parentheses really weren't necessary, but it's a good habit to be in. So I'm going to clean up all of this. So I end up with 2 sine theta cosine squared of theta plus, I'm going to distribute this in, and I end up with cosine squared theta times sine of theta, but since I have sine theta cosine squared here, I'm going to just reverse the order and put it as sine theta cosine squared of theta minus, and this is going to give me sine cubed of theta. Okay, now I look at where I'm trying to get here and what I've got. I guess I can combine these together. So remember, there's no recipe to follow to solve an identity, or to prove an identity. You just have to keep trying things, and sometimes what you're trying won't work, and you have to try again, and you have to accept that. When I look at this, I see some things that are working, and then other things that don't look so good. I have a sine cubed. I need a sine cubed, but this is 4, and I've only got 1. I do have a minus sign, so that's helpful. I have a sine theta cosine squared theta, and I really just need a 3 sine of theta, which is this. So I need to this is wrong. I can't have this in here. I need to make that go away somehow. So I think about my identities, and I'm trying to find something where I can get rid of a cosine squared and change it into a sine somehow. So I go back to my Pythagorean identities, and I know that cosine squared, I'll drop this down up here, cosine squared of theta is equal to 1 minus sine squared of theta. So I'm going to make that substitution and see what happens. So I have 3 sine of theta, parentheses, 1 minus sine squared of theta, minus sine cubed of theta. I'm going to distribute this in. So I have 3 sine of theta, so far so good, that's what I wanted, minus, when I multiply this in, I get 3 sine cubed of theta minus sine cubed of theta. And now when I combine these together, I end up with what I'm looking for. Now, proving identities always looks easy when somebody else is doing it. And you have to be patient and persistent and don't always expect to get these on your first attempt. A lot of times you have to try things 2 or 3 times before you find something that works. It's good if you're working with other people, and then you can all try different ways and hopefully somebody gets it quickly, but a lot of times it takes several attempts before you get the right answer. So these things, these identities I'm putting up here right now are just ones that if you're keeping a note card would be good ones to put on there. These are just manipulated formulas, so they come from other formulas we've already used, but they're going to be helpful to you in solving, well, problems in this homework set, but just problems on the test and quizzes that you might encounter. So I've got 2 more formulas for the cosine of 2 theta, and then I've got a couple formulas, one for cosine squared and one for sine squared. Notice that these reduce that power down. My book refers to these as power reducing identities. So anytime you're trying to reduce something from a higher power down to a lower power, you're looking for these power reducing identities, and they will come in handy. Remember, if you have something in tangents, you can always write those in terms of sines and cosines, so you'll still be able to use those. Okay, so we're going to use one of these new manipulated formulas here. And this will be our last example. They want us to express the cosine to the 4th power of theta in a form that does not involve powers of the trig functions. So they don't want any power higher than 1. So there should be no powers on this. So I start by writing cosine to the 4th. Now, I have this power reducing formula, but this is only for a square. So what I want to do is break this apart and think of it as being cosine squared of theta squared. Okay, so I'm going to square that, and I'm going to kind of do this in a couple of steps to get that power completely gone. So the first thing I do is I look at this and I say, hey, I have something I can substitute in. So I can rewrite that as 1 plus the cosine of 2 theta over 2, but I have to square that. The whole quantity has to be squared. You can't forget to do that, which a lot of times we do, myself included. So I'm going to go ahead and expand this out. So I'm going to multiply this out, and I end up with 1 plus 2 cosine of 2 theta plus cosine squared of 2 theta all over 4. Okay, so I have to square the denominator also. I'm going to go ahead and break this down into, I'm going to distribute that 1/4 through to each term, because notice I have another squared here, so I'm going to have to do that power reducing on this piece, and I would rather have that just be one fraction rather than this big involved fraction. So I'm going to write this as 1/4 plus 2 cosine 2 theta over 4 plus cosine squared of 2 theta over 4. Now on this one, I'm going to substitute in that power reducing formula again. Okay, so the first 2 terms are going to stay exactly the same. So I have 1/4 plus 2 cosine 2 theta over 4. Now I'm not reducing this on purpose because I have this common denominator, and I don't know if maybe at the end I'm going to be able to factor that out or do something with it. If not, at the end I'll put it all back and reduce the fraction or something, but I'll decide what to do with that later. So I don't like reducing and then have to build it back up if I don't have to. So on this one, the cosine squared of 2 theta. So I have to be very careful when I do this one, because my angle, when I do this theta is a 2 theta, and it's going to get a little confusing over here. So I have the quantity 1, let's work with it, 1 plus cosine of 2 theta, but in this case theta is 2 theta. So it looks like that. And the whole thing is over 2. And then that is also over 4, that 4. Okay, so this top part here is that power reducing identity, and then the 4. So I have 1/4 plus 2 cosine of 2 theta over 4 plus, I'm going to think of this as being 1/2 plus the cosine of 4 theta over 2, and this is all over 4. So when I simplify this new denominator for these two is going to become 8. I'm going to come up here. So I have 1/4 plus 2 cosine 2 theta over 4 plus 1/8 plus cosine of 4 theta over 8. So I actually have this one simplified. Notice there's no powers, but I have two constant terms. I want to combine those together. I see that I have a common denominator I can make a common denominator of 8. So I'm going to make everything with a common denominator of 8. So this will become 2/8. This will become 4/8. And now when I write this, I have my common denominator of 8. I'm going to combine my 2 and my 1 and get 3 plus 4 cosine of 2 theta plus the cosine of 4 theta. So this is as simple as it goes. It would be correct if you wrote this as 3 separate terms, 3/8 plus 4 cosine 2 theta over 8 plus the cosine of 4 theta over 8, or if you factored that 1/8 out. So there's multiple ways you could show this answer, but this is considered reduced. This is just the way I usually prefer my answer, but it doesn't mean it's the only way. Same thing with this one. There's other ways you could have maybe written this to get started, but our final answer is always going to come out the same. So when you're working with these, I encourage you to work together and compare answers, but remember there's multiple ways to do it, but the final answer should be the same when you get done. So be sure and compare answers and work together, and good luck on these problems.